Alright, so this is the first part of 2.3 polynomials, and so we're going to look at the first section, and I'm going to do problems 5 and 6, and we have one of each type. For both of these problems we are factoring, looking for, so set it equals 0, factor, and go from there, which we've done before, so this shouldn't be new, this should be a review. So I'll set it equal to 0, and I'm going to try to factor it, and the first thing we're going to do is see, is there anything I can factor out of everything? Well, whenever my first term is negative, I'm going to want to factor out a negative. I see a 4, a 12, and a 9. 2 divides into 4 and 12. 4 divides into 4 and 12, but not 9. 3 divides into 9 and 12, but not 4, so no constant I can factor out. But I see that there's an x in everything, so I can factor a negative x out. And when I do, that leaves me with 4x squared plus, because I factored a negative out, 12x plus 9. Alright. Well, I need to factor out that middle part, and because the leading term has a constant, in this case of 4, I'm going to use my little box to help me. And I'm going to say, alright, I have a 4x squared and a 9, and I'm going to think what multiplies to make those. Well, I'm going to start by guessing, and I could be wrong, we'll see, that we're going to use a 2x and a 2x. It could be a 1 and a 4, but I'm going to try 2x and 2x. And then I'm also going to say, well, 9 is also a perfect square, so what about 3 and 3? Maybe they gave me a perfect square trinomial here, and let's see if that worked. 3 times 2x is 6x. 2x times 3, 6x. And if I add those two boxes together, I do in fact get 12x. So I can come over here and say this is negative x, and then 2x plus 3, 2x plus 3. And I'm going to set each part equal to 0. So I have negative x equals 0, 2x plus 3 equals 0, and another 2x plus 3 equals 0. And we'll scroll down a little bit. So for this one, I'll divide both sides by negative 1, and I get x equals 0. There's one of my roots. For this one, I'll subtract 3 and get 2x equals negative 3. Divide by 2. X equals negative 3 over 2. And I see this one's exactly the same, so this will give me another x equals negative 3 over 2. So this root right here occurred twice. Well, if you remember when we talked about that whole multiplicity, we said that if it occurs twice, it has a multiplicity of 2, which means that the graph is going to come down, touch the x-axis, and go back up, or vice versa. So I'm not going to actually leave my answers like I have them circled. I'm going to say my roots are x equals, and I'll list them out. I'll go 0, that's one of my roots, comma, another root I have is negative 3 halves, and it has a multiplicity, which I'm just going to put mult period, of 2. Our next one only has 2 terms. Well, when I have 2 terms, I'm just seeing what can I factor out of everything. Well, I see I can factor, I want to factor a negative out because I want my first term to be positive. I'm setting it equal to 0. Factor a negative out. Can't factor a constant out, but I can factor some x's out. Specifically, I can factor 3x's out, leaving me with x squared minus 4. Okay. For our purposes, I'm going to want to think of this negative x cubed as negative x times x times x. All right. And then this right here, well, this is a perfect square minus a perfect square, which means this is a difference of squares. I don't know if that has one F or two F's, but we'll give it two F's. Difference of squares. So, for instance, if I have a squared minus b squared, I can factor that into a plus b, a minus b. So for this one, I'll factor in the two parentheses. My a is x, because this is x squared, so I have x. What multiplies to make 4, or what's the square root of 4 rather? Well, it's 2. 2 and 2, and then 1 positive, 1 negative. Alright. So that's how I factor a difference of squares. Now I'm going to set each part equal to 0. And as I look at this, I think, okay, well, I got 3 x's. Those are all going to give me the same root. And I have these two. And they look similar, so I might be tempting to think they give me the same root, but one's positive, one negative, so this is going to be two different roots. So let's start off with my x's. I have x equals 0. There we go. And it, excuse me, it occurs 3 times. So we know we're going to put a mult 3 on that one in a second. I also have x plus 2 equals 0. I'll subtract 2 from both sides and get x equals negative 2. Here I got x minus 2 equals 0. Add 2 to both sides and get x equals positive 2. And then I'll write my final answer out. And I'm going to list the ones that don't have a multiplicity first, just make it look a little better. So I have, let's see, which ones have a multiplicity of just 1? Well, that one only occurs one time, so x equals negative 2. X equals positive 2, so I could let comma positive 2, or I could put plus or minus 2, because plus or minus 2, I have both positive 2 and negative 2. They would both occur one time. And then I have 0, and it occurs 3 times, so a multiplicity of 3. Alright, and then we get to this one. This one might look very different, but essentially we're doing exactly the opposite of the first section. So here, in the first section, they gave me a polynomial, asked me to find the zeros. Here they give me the zeros and ask me to find the polynomial. So we're going to work our steps backwards. So if you remember, we end up in the last part with x equals a value, x equals a value, x equals a value. That's how I end the problems in the first section, with x equals numbers. So this is how I'm going to start this one. And in the last one, normally they're set equal to 0. So I am going to set them equal to 0. I'll do the middle one first because it'll make a little more sense. This one I just add 4 to both sides. X plus 4 equal 0. Alright, well there's that one. The other two are fractions. And I don't want fractions, not because I just don't want fractions, but my instructions specifically tell me that my coefficients have to be integrals. That's what it means by integral coefficients. So I don't want fractions, and I want to get rid of them right now. So we're going to get rid of them right now. So we're going to multiply by the denominator. In this case, that means multiplying by 3. So I have 3x equals 1. And over this side, multiply by 2, giving me 2x equals 5. And then I want to still set them equal to 0. So I'll subtract 5 from both sides, giving me 2x minus 5 equals 0. And over here, subtract 1. 3x minus 1 equals 0. Alright, so that's how I get them set equal to 0. Hopefully that makes sense. Well, think about it. I set things equal 0 when they're all multiplied together. So in the previous set I meant. So normally I factor and then set each factor equals 0. Well, we're going backwards, so I have things set equals 0, so each one of these is a factor. I have 3x minus 1. I have x plus 4. And I have 2x minus 5. Those are my factors. Okay? And again, I'm going backwards. So if I go backwards, then instead of factoring, I'm multiplying them out. So I need to multiply these together. I have 3 different things here. I can only multiply 2 at a time. So I'm just going to pick 2 of them to multiply together, and I'm just going to multiply the first 2 together. And I'm going to set up a box to do that. I have a 2 by 2, so I'm going to set up a 2 by 2 box. 3x minus, 3x, ignore that, minus 1, x plus 4. So if I multiply, 3x times x is 3x squared, negative 1 times x is negative 1x, 3, 4, 12x, 4 times negative 1, negative 4, and I can combine those two middle terms. So when I multiply those together, I get 3x squared. 12x minus 1x is plus 11x, and then minus 4. But I haven't used this one, so I need to keep it listed. 2x minus 5. Alright. Well, now I need to multiply those two together. And this will be the last thing that I do, and then I'll have my polynomial. Well, this is a 3 by 2, so I need to make a 3 by 2 box. I always make mine horizontal. You can make yours vertical. By that I mean I have a width of 3 and a height of 2, but you can make it a height of 3 and a width of 2, and it still works the same way. Alright, so I have 3x squared, 11x, negative 4, 2x minus 5. By the way, if you've never used the boxes, all they really do is just help me visualize distributing. So really I'm just distributing, and then distributing, and then distributing. So if you're more comfortable with that, not a problem. Does the exact same thing. Alright, so let's multiply them. 3x squared times 2x is 6x cubed. This gives me 22x squared, negative 8x, negative 15x squared, negative 55x, and positive 20. And I'm ready to write my final answer. My final answer should start off with either y equals or f of x equals, if you want to be fancy, doesn't matter. And then I'm going to combine like terms if I have them, starting with the highest power. So I have 6x cubed. These two boxes combined, 22 minus 15, let's see here, that would be 7. So positive 7x squared. These two boxes combined, 55 plus 8 should be minus 63x. And then I have a plus 20. And that is the polynomial. That's my answer. And just remind ourselves what we did, because that was a bit of a long process. That's the polynomial that if I graph it, it crosses the x-axis here, here, and here. So it's the polynomial that has those 3 roots. Alright? I'm going to check to make sure. Alright, so I was going to try to do one more, but I am out of time for this video. So if I get a chance, I'll make one for the next problem later, but otherwise go ahead and try the rest of those. The answers are at the bottom of the classwork paper. So if you're looking on the classwork PDF on our Google Classroom, you can find the answers on the very bottom and check your answers there. As always, contact me. I'll remind if you have any questions. Good luck, and I will see y'all tomorrow.